In this video, what we're going to talk about is density. First of all, density is what we call an intensive property. It doesn't matter on what size a particular variety of substance is, its density will always be the same. For example, something like gold, it doesn't matter if we have a very small piece of gold or a very large piece of gold, the ratio of the mass and the volume will be equivalent. Extensive properties, on the other hand, are size dependent. So things like mass is an extensive property, or volume. Those two things are both extensive properties. Now, when we look at gold and brass, they both have a gold sheen to them. And what we have to consider is, how do we tell the difference between these two substances? If we just say weight, one of them is gold is heavier than brass. Well, we're talking about the mass of this object, and the mass of gold can be exactly the same as the mass of brass. In fact, the volume of the gold and the brass could be equal also. But if the volumes are equal, then the masses aren't equal. And if the masses are equal, the volumes aren't equal. And so the relationship of the mass of an object and its volume give it its density. And so we could actually look at gold and say, well, the relationship of mass and volume is larger, or in other words, its density is larger than that of brass, and we can determine the difference between them. So what we're going to do is we're going to look at, first of all, the equation for density. Density is simply the mass divided by the volume. This could be in grams per milliliter. It could be in kilograms per liter. It could be in grams per centimeter cubed. Okay, anything to do with mass divided by volume. And so if we work out a density problem here, density is equal to, if we look at this problem, mass is measured in grams, so we have our 20 grams divided by, and over here we have our volume, 24.3 milliliters. And so what we're going to do is, we'll pull the calculator up. So we got 20 divided by 24. So you have 20 grams divided by, and I'm going to throw a parentheses in here, 24.3 milliliters. And press enter. And then you'll notice we get 0.823 grams per milliliter. So we'll jump back. This is equal to 0.823 grams per milliliter. Now, one of the things I have to consider here also is that I have three significant digits. That zero there is significant, so we have 3 there. We also have 3 here because that 3 is our last digit, and those two are considered significant also. So we have 3 there. So when I'm all done, there's my significant digits. Okay. So let's move to another problem. Piece of metal has a density of 4.32 grams per milliliter. How many grams? So we're hunting for grams this time, and we're given milliliters. So what I'm going to do is I'm going to start out with the thing that only has one unit. So I take 30 milliliters, and I'm not worrying about the equation. I'm actually doing this dimensionally. So what I do is I set up my goalposts. I want to get rid of milliliters, and I want to go to grams. Well, if we look at this density, this really means that there are 4.32 grams in 1 milliliter. So that's what I'm going to write down. 4.32 grams in 1 milliliter. And so then I have to take 30 times 4.32. So 30 times 4.32. And we get 129.6. 129.6 grams, but we have 3 significant digits, so it really equals 130, and I'm going to put the decimal behind this to indicate that it is that last 0 is significant. Okay, moving on to the next one. Notice that our units are a little different here. It's kilograms per liter, but it's still correct. It's mass over volume. We have kilograms this time, and we want liters. So I'm going to start out with my 400 kilograms. Now notice I have 4 significant digits here. I also want to get rid of kilograms, so kilograms are going to go on the bottom and liters on top. So I go back to my density. This is 8.94 kilograms over 1 liter, or 1 liter is equivalent to 8.94. So I'm going to take 400 divided by 8.94, and we get 44.74. So 44.74 liters, but we have a density of 3 significant digits. We're gonna take this into account that this may be 3 significant digits, and not just worry about the measurement in this particular case. So we're going to have to write this as 44.7 liters. Okay, let's look at the next one. Now here's another difficult problem, because what we have to do is a lot of conversions along the way. We have a density. Okay, so I'm going to underline some things that are important. There's my density. Here's my length, and I have 3 lengths. And if you remember, if we have 3 lengths and it's a rectangular solid, what we're looking at is to do length times width times height. Now I know a couple things. First of all, 1 decimeter cubed equals 1 liter. Also, 1 centimeter cubed equals 1 milliliter. And we also know that 1... oh, well, actually, we'll skip this for a second. We'll kind of work off of this right here. 1 decimeter cubed equals 1 liter. So what I'm going to do is, first of all, look at my units of length and get them into decimeters. So I have 1 meter, and I want to convert that to decimeters. So I'm going to get rid of meter, go to decimeter, and there are 10 decimeters in 1 meter. This makes it kind of nice for me. So I have 10.0 decimeters. And if you kind of follow the same logic on all of these, we also have 5 decimeters, and then this is going to be 20 decimeters. Oops, I got one too many. 0. We'll scratch him out. So now I need to get the total volume of this thing. So I'm going to take 10 decimeters times 5 decimeters times 20 decimeters. And I'm going to multiply those together to get me a total volume. 10 times 5 times 20. So we get 1,000 decimeters cubed. Okay, so this is 1,000. Now that's a significant decimeters cubed. So now we have a volume, but it's in really it's in liters. So let's do a little more conversion. So I'm going to bounce down, and we're going to start out with our 1,000 decimeters cubed, which I said is actually equal to a liter. Now what we want to do is we want to convert this, get out of liters, and let's go to milliliters. And there are 1,000 milliliters in 1 liter. The next thing I want to do is I want to get rid of milliliters, and I want to go to, if you remember, if we scroll up here, it's 11.34 grams. So let's get that into grams. So this is 11.34 grams for 1 milliliter. Now, if you look at the units, if we start canceling everything out, liters cancel out, milliliters cancel out. Right now we're in grams. And so the next step would be, instead of, I asked for kilograms in the problem, so let's just convert that also. So I get rid of grams, and I'm going to go to kilograms. So this is 1 kilogram is 1,000 grams. And so now, notice that the 1,000s, which makes our life kind of easy, those 1,000s actually cancel out. And all we have to do is take 1,000 times 11.34, or I forgot our grams there. 1,000 times 11.34, so we get 11,034 kilograms. Let me write that a little better. Also, we got to consider that we had 3 significant digits, so it's actually 11,300 kilograms. So it's a number of steps that we had to go to to get there, but we have to consider that as we do these type of problems.